So just an FYI, this is section 5.2. 5.1 was solving systems by graphing. So now we're looking at what you can do algebraically so that you can get a more exact answer, especially if you don't have a whole number answer. So the first step is solve either of the equations for one variable in terms of the other. So in the system of equations, has one of the equations been solved for x or y? Do you look at that? Yes, no? Chris, put that down. Thank you. Do we have y or x alone in one of these equations? Yes, we do. The first equation is y equals negative x minus 1. So this one in the example is already done. So you don't always have to do that step. Sometimes it's already done for you. So I'm just going to rewrite this down here. The next step is to substitute the expression that you got alone into the other equation. So in this first equation, I know that y equals negative x minus 1. So I'm going to take this whole expression and I'm going to substitute it in for y in the other equation. So when I rewrite this, I'm going to write 4x minus 3, and then what am I going to put instead of y? What does y equal? Come on, you guys can do this. What does y equal? What did I just circle? Negative x minus 1. So instead of writing y here, I'm going to put in parentheses negative x minus 1. And then the rest of this equation equals 24. The next step then, look at a little line here, is to solve the equation. So I'm going to distribute this negative 3. So I'm going to drop down the 4x. I'm not going to use that yet. Negative 3 times negative x. Negative times a negative will give me what? So positive, so plus 3x. And then negative 3 times negative 1 is what?
3.
Positive 3. So plus 3 equals 24. My next step in solving is to combine like terms. So what two things can I combine here? 4x and 3x. And that gives me what? 7x. So 7x plus 3 equals 24. Can I combine 7x and 3? No. Huh? So can I just combine 3 and 24? What do I need to do?
You need to add 3.
Add 3? No, we're not going to divide. We need to get that 3 to the other side.
Wait,
And I think you had it.
no. Are you using the first one first?
Yeah. So I'm going to subtract 3 from both sides.
Wait, that's what equals.
Yep, sorry if that wasn't clear. So I'm left with 7x equals 24 minus 3 is 21. What is my next step?
You need to
Divide both sides by 7. So I have x equals, what's 21 divided by 7? 3. So I take my original equation, y equals negative x minus 1. I'm going to take that 3 and I'm going to put it in for x. So y equals negative 3 minus 1. What is negative 3 minus 1? Negative 4. So y equals -4. I now have my x and y, and I'm going to take that x and y and check it in my other equation. So the last step is to check the solution in the other equation. So if I have 4x minus 3y, I know what I've gotten so far is that my x equals 3 and my y equals -4. So I'm going to put 4 times 3, because that's the value I have for x, minus 3 times -4, because that's the value I got for y, equals 24. And I'm going to check and make sure, I'm going to do the math and make sure that that is correct. So 4 times 3 is what?
12.
12. And -3 times -4 is +12. So plus 12 equals 24. I'm just dropping this part down. And does 12 plus 12 equal 24? Yes, it does. So my solution then is the point, and you want to write your answer, the coordinate, when possible, if you remember, is the point 3, -4. Sorry, gotta zoom out a little. And that is the step-by-step on how to solve systems of equations using substitution.